In this video, we're going to create this effect where Suzanne's being electrocuted by a lightning bolt. And the things you're going to learn in this tutorial are hdri lighting with light paths, expressions, what vectors are and how we can use them in geometry node. We'll look at instancing. We'll use editing of geometry and moving around individual points and selections. We'll use attribute transfers to transfer information from one set of geometry to another one. We'll look at groups, randomisation of values, turning things into meshes. We'll set up shaders and materials. And we'll also look at how we can create custom attributes we can generate inside of the geometry node tree and then use those in different areas of Blender. And if that wasn't enough, we're also going to look at how you can use the compositor, how you can render, and how you can render up to 100 times faster using EEVEE. If you want the scene file, you can download it from 3d-illusions.co.uk. If you're a member, then it's free. It's in your download section. If you're not a member, then you can get it for a small fee. So let's start off by creating a Suzanne, or any object you want, doesn't have to be Suzanne. And we'll create a camera. And we'll just find a nice angle, maybe somewhere about there. Then we'll align the camera to the viewport with Ctrl-Alt-0. And then let me just turn on lock camera to view so I can move the camera around as I would normally move the viewport. Somewhere about there perhaps. I'll probably change that focal length a little bit as well. Maybe something like that. And I'll uncheck lock camera to view so I don't accidentally move it. Come back out of camera view. I want to drag up a new editor from the bottom here. And I want this to be a geometry node editor. So we'll select Suzanne. We're going to give Suzanne a new geometry node system. And we need something to emit the lightning from. So we're going to use a UV sphere. And I want to be able to see them both as well. So we'll go with the join geometry. We'll connect this in so we can see both. We'll go into camera view. And I want to make sure that the sphere is just outside, its bounds are just outside the camera's bound. Because when the lightning emits from it, I don't want the lightning to appear as if it's emitting in mid-air. So I need it to be emitting from off-screen. Alright. And we also need to remove the back of the sphere, because obviously that will look as if it's emitting from mid-air as well. So go into wireframe mode. I just want to delete the back half of the sphere. And to do that, we can use the vector. And a vector is basically a line between the origin and the object, and also between the origin and each point of the object that we want to delete from. And we compare these lines, and if they're pointed in the same direction, we want to keep them. If they're pointed in the opposite direction from the camera on the sphere, then I want to remove them. And this is really easy. All we need to do is use something called a dot product, a vector math dot product function, which compares two vectors. So Shift A, S, vector math, and then Shift A, S, we're going to delete the geometry, and we're going to go with a dot product on this vector math node. And we need to bring in the object for the first vector, which is going to be the camera. So drag that in and plug its location in there. And we need to compare it to the position of each point on the sphere. So we can do that if we plug that into the selection, then we can Shift A, S, and get the position of each of those points of the sphere by plugging that in there. If you're not sure of how the fundamentals of geometry nodes work, check out my video on 3d-illusions.co.uk. It's called EEVEE Huge Oceans Part 2. And that is dedicated to teaching the fundamentals of geometry nodes. So you'll understand basically everything that I'm talking about. Alright, so we've got the dot product in there. What we need to do now is compare the dot product. So we need to say, what is that dot product equal to? So Shift A, S, I'm going to drop down a normal math node this time and change this to greater than or less than. We'll try less than. And you can see we can control the threshold. Let's come out of wireframe mode. The threshold here will control the angle, the difference of the angle between the vectors. So we could have normalized it and it would have been 0 to 1 and 0 to -1, but this should be fine. And also, one problem you might encounter is if you move the sphere, you'll notice that the vector is still returning the same difference, and it's not sort of, you'd want it to be moving around. And to change that, we just need to make sure that the camera is using the sphere's origin rather than the origin of the world. So we just change this to relative, and then as we move this around, you can see it's now working correctly. And now we need to make something for the lightning to emit from. And we don't want it to emit from just the point. We could do, but just to have a little bit more control, we'll scatter some points on the sphere. So points on face. And then now we're going to put these into a frame. So Shift P, bring up the side panel, and we'll change the frame name to create lightning emitter. Okay, and now we need something to emit the lightning onto on the Suzanne. So we'll do this exactly the same thing. We're just going to copy this one, so Shift D, and I'll press Alt P so it's no longer inside of the frame. Put that on there, and now you can see we've also got points on Suzanne. Now what I want to do is create the lightning, which is basically going to be a curved line. And a curved line is by default 2 points, so the start point and the end point. Shift A, S, and I want to instance these onto the points of the sphere. So it's going to be on this branch here, not on this branch here, that would be Suzanne. And then put the curved line into the instance, and you can see we've now got, instead of the point, we've got these lines. I want each, because these have both all got, each one of these has got 2 points. I want 0, the first point, to remain on the sphere, and I want 1, which is the second point, to connect up to one of the points on Suzanne. And to do this, we just need to say Shift A, S, set position. We also need to realize the instances, so they're actual geometry, not just instances. So realize instances. And I want to get the position information from the individual points of Suzanne. So I'm going to use Shift A, S, and we need to use something called a transfer attribute. So a transfer attribute is going to get an attribute from one mesh so that we can use it on another one. And obviously we want the position attribute from these points on Suzanne. So Shift A, S, and we'll say position. We'll make sure we set the target to be the Suzanne point, and then position goes into the attribute. We need to change this to vector first, and then position into attribute, and then the new position is going to be plugged in there, and now all those lines, the points on the lines, have moved across here. Now you can see at the moment it's giving us an error, and that's because it's saying we need to use a mesh because the method we've chosen to transfer is the nearest face. Obviously we've only got points, so we could go with nearest. That will give us this result, or we could go with index, and that will give us a different result. So I'll show you why we're going to use one, not the other, in a second. But the first thing we need to do is make sure we're only moving, put that back to nearest temporarily. We want to make sure we're only moving the second point, so the end point, not the initial point. And this is really easy. We just use something called a endpoint selection. And this will get either the start or the end of the curve of each of those lines with a fall off of how many we want. So we don't want any. Plug that into the selection, it's going to stay the same, and that's because it's still moving both points. So we just need to say don't move the start point. We don't want any start points to be included in the selection. So 0, and now you can see all of those start points are still on the sphere, and the end points have all moved to the nearest point on Suzanne, because we're transferring the position attribute onto the end point of each curve. Now obviously we don't want this. They're all sort of pointing to the same points based on proximity. We don't really want that. What we want instead is it to be a little bit more random. So we're going to change this to be index instead of nearest. And there we go. But the problem is now you can see we've still got a few lines that aren't pointing anywhere. They're going straight to the origin instead of a point on Suzanne. And that's because we've got more points coming out. We've got more lines than we've got points on Suzanne. So there's two options. We can either reduce the number of points on the curve, which is done in the where we set up the points on faces, so we can reduce the density there until we've got less points on the sphere than we've got on Suzanne. Or if we want them all, we can increase the density on Suzanne until we've got them all covered. So the method I'm going to use is to reduce the number of lines, because I don't want that much lightning anyway, and it's going to get quite intensive on the computer if we've got too many. Right, so we've got that many lines. That's probably still a bit too many. Let's turn that down a bit more. Alright. What we need to do now, obviously, this doesn't look like lightning. It just looks like straight lines coming from one object to the other. So we need to add a little bit of noise to this. And we also want to get rid of these points. And before we get rid of the points, I just want to show you how we're going to animate these. And basically, we're going to go into the distribute points on faces, and if we change the seed, you can see those points on the sphere are moving around. And if we change the seed on Suzanne, you can see they're moving around on there as well. And that's how we're going to move the lightning. So we can go onto both seeds, and just animate these with a simple hashtag frame. And if you divide it, the higher the number, the slower it's going to be. So this is 24 frames per second at the moment. So if I divide the frame by 24, then that means it's going to change once every second. So it's a bit too slow. I'm going to change it to something like 10. Something like that. And we also now want to make the lightning move around on Suzanne's surface. So we go over here, and this time I want it to be a little bit quicker, so that the lightning jumps around faster on Suzanne than it does on the sphere. So frame, I'll just leave it as frame as it is. And there we go. So now it's dancing all over the place. That's looking pretty good. Alright, so now we've got that set up, we can forget about the points, and we'll bring Suzanne across instead. So I'll copy the geometry, the group input, and I'll plug this into the join, and now we've got Suzanne back. So the next thing to do is make these lines look like lightning. And before we continue, let's just organize these. So let's move on. The next thing is we're going to make these look like electricity. So Shift A, S, we need to move these points around. So set position, Shift A, S, go with random value, and we want it to be a vector. And we want it to be between -1 and 1. And that will ensure that the random number can move it in both directions. If we just have it 0 to 1, then it's only going to move in one direction. So for example, left would be a negative number, right would be a positive number, 0 would be no movement at all. So if we have that 0 to 1, the lightning will always be randomly moved in one direction, and it'll just look weird. So let's put this into the offset. And at the moment, we're not getting much happening because there's not enough resolution on the curves. So Shift A, S, resample curve, put that in there. And then we can increase the number or decrease the number of samples. Maybe somewhere like that initially, because we want a larger sort of noise, and then we'll put a smaller noise on top of that. And this is way too much. So rather than changing these manually, Shift A, S, I'm going to put down another vector math node. We'll just minimize this one. Shift A, S, and then value. So we can control all three of these vector values with a single value. Change this to multiply, and then control the strength using that one value. Now, you'll notice at the end, it's also moving the points away from Suzanne, which we don't want. So we'll drop down a second multiply, and just copy this one across. And we want it to get stronger at the beginning and weaker at the end, the effect of this random movement. So Shift A, S, we're going to use something called a spline parameter. In your version of Blender, if you're on prior 3.1, I think it's called curve parameter. But either one of those, as long as you've got the factor, and the factor just defines the length normalized to 0 to 1. So 0 is going to be the start, 1 is going to be the end, regardless of how long it is. So plug that in there. It's the wrong way round. It's still moving the end, but it stopped moving this end. So we just need to invert the factor so that it goes 0 at this side and 1 at this side. Shift A, S, range, drop that in there, and we'll just change this from 1 to 0, and now it's sticking again on this side. So they're still sticking to Suzanne. We've got more noise towards the sphere. So let me add a little bit more. I think we'll add a few more, maybe not quite that much. Something like this. So that's the first noise. I want to now add a secondary smaller noise onto that as well. So let's go with, grab all these, and we'll just do a Control G. And that's going to group them together. And I want to plug the count from this resample into the outside, so I've got control over that. And do I need control over anything else? Maybe, we'll come back to it if we do. So we've got this group now. I'm going to call this group Make Lightning. And then we'll Shift D to copy this across, and we've got a second one now. We can change the count. And also, I do want to have access to the strength. So instead of using a value here, I'm going to plug this in over here. And then we'll go into the group input settings, see if we can change this to a single. Oh, we can do that. That's great. So we'll change that to a float, and I'll call this vector scale. Let's come back out. So then that's the main one, and now we've got the smaller one. We need to increase the count and turn that scale down. You can see we've got this happening along there. So that's looking quite good. Go into camera view. We've got that lightning effect. Now we can make additional tweaks. If we're not happy with the animation, we can speed it up and things. But also, we want to not always put one of those lightning bolts on the sphere. So we can just add a bit of probability, a bit of randomness to that. Shift A, S, and we'll go to random value. And we'll just change this to a Boolean, so it's either 1 or 0. We'll plug that into the selection. And then we can change the probability. If we turn the probability down, we're going to get none. Turn it up, we're going to get less. And if we change the seed, it's going to move them around. So maybe somewhere about there. Looking pretty good. Okay, so let's put these inside of a frame as well. And we'll call this Make Look Like Lightning. Move that across. And then we need to add geometry to the lightning so that we can add a material to it. So Shift A, S, curve to mesh, drop that in there, and Shift A, S, we need to give it a cross section, which is going to be a circle, a curved circle, importantly, and then plug that in there, and you can see we've got this massive oversized thing happening. We can turn the scale down using the radius, but the problem is, if you zoom in, you can see that radius, just to stop the animation, is the same width all the way down. So we need to control the scale based on the length. When we can use what we used before, which is the parameter. So we use the factor along the mesh. So drop down a set radius, set curve radius, drop that in there. Shift A, S, spline parameter, plug the factor in to the radius, and we need to invert it so it's going the other way. Shift A, S, range, drop that in there, and then 1 to 0. And if it's a bit too linear, if you want it to sort of get thinner more slowly towards the, or quicker towards the end and stay thicker in between, can actually use something called a float curve, drop this in, and this will control how that gets distributed along. So if you wanted it faster, for example, at one end, you can do that. That's looking pretty good to me though. So the next thing is the materials. In fact, before we do that, tidy this up. And let's just subdivide Suzanne while we're at it. Shift A, S, subdivision surface, make it 2 subdivisions, and then we'll also make a smooth. So set shade smooth, plug that in there. We can add the material now. So Shift A, S, set material. I'll drop that. In fact, let's put this Alt P. Let's put these over here, and then I'll duplicate this one, and I'll select both of these. Shift P, and I'll call this set material. So let's create those materials, and we'll also switch to EEVEE rendered view. Let's just turn off the scene world and go into the material tab, click new, and new again, plus again, and new. So the first material, I want this to be a metallic material for Suzanne. And we'll turn the roughness down. And then we need to assign it using this one, the top one. And then for the second material, I want this to be a lightning bolt material, so we just want it to have some emission. So let's turn the emission to white. We'll make the strength maybe 40. We'll go to the render settings, turn on bloom, and make sure we assign it. And there we've got the lightning. If we go into the bloom settings, we can probably give it a bit of a blue outline. Something like that. If we play this back, we can see we're getting this sort of an effect. Maybe I'll increase the speed a little bit, I think, of the movement on the sphere. So I'll make this 3, and it'll just move around much faster. And I can even increase the speed on here as well, so times 3. Whatever you think looks best. And the last thing I want to do is make Suzanne, when something gets electrocuted in cartoons, normally you can see the bones coming through. Obviously Suzanne doesn't have bones, she's got wireframe. So I want the wireframe to be electrified as well. So to do this, we need to create, let's go into the shader editor. And we'll make sure we've got the Suzanne material selected and just click home so we can zoom in on it. And we'll do Shift A, S, wireframe. And let's plug this into the emission. Into the emission strength rather. And then we'll change the colour to white. And we want it to be brighter than 1, so we're going to give it a value of maybe 40. That's probably a bit too much. Let's go with 20. Maybe 10. And I don't want it to be on all the time, and I want it to be a bit thinner as well. So let's go with 0.005, maybe even less, 0.002. Right, so I want this to flicker, and we can control that from inside of the geometry node. So in the group output, we can pass any data out. So I'm going to go with let's go with a noise, so noise texture. And we'll plug this in there. We'll change it to 4D, so the 4th dimension is the time. And we'll just give this frame, and we'll decrease this a little bit. And what we can do now is we go over to the output attributes in the modifier. You can see we've got this new one called FAC, which is what we've plugged it in here. We can change the name in here if we want to. If we go into the group tab, we can rename this whatever we want. But it doesn't really matter beyond us knowing what we're connecting into on the group output node. The important part is what is called in here. So I want to call this or electrify. Let's call it electrify. Now we've got an attribute on this geometry, which we can actually see if we go into the spreadsheet. Let's come over here. You can see we've got this new attribute called electrify. If we delete this here, then it's gone. I'll just add that back in. Okay, so we need to somehow access the electrify attribute from inside the shader editor. And it's really easy. Shift A, S, drop down an attribute node, and just give it the same name that we've got in there. So electrify. And we want this noise to sort of send out a flickering signal that will change between the wireframe and nothing. So we need Shift A, S, mix RGB. True is going to be the bottom one, and false is going to be the top one, which will turn to black so that it gets no emissions at all. Now we plug the factor from the attribute into the factor of the mix. Give it a second. And now, if we change the scale, it's going to start having an effect over here. Let's turn the roughness down. We change the scale to 0.1. And at the moment, it's going 0 to 1. But it's a gradient. So we're not really seeing the effect very strongly. We've got a couple of options what we can do. We can either take care of it in here, in the shader editor, using a ramp. And just slide these closer together. So that's one way we can do it. And then if we press play, you can see that's moving around. Or we could do the same thing in here. So we'll probably go with it in here just for kicks. So we're finished with the shader editor now. Let's bring this across. So the easiest way to do it is with a math node. We'll just do math, and we want to round it to the nearest figure. So the round function, and then you can see it's either going to be 0 or 1. If you play that back, that's moving around as a 0 to 1. I think I might make those a little bit bigger actually, the wireframe in the shader editor, because it's difficult to see during animation. So shader editor, home, scroll in, I'll set this to 0.01, 0.005. Should be easier to see now during playback. Alright, so we've got that set up. At the moment, it's got a very obvious pattern of movement. We want to break it up a bit so that it flickers. We'll turn that distortion down temporarily. So this can be the flicker. Maybe 0.2. And if we change the speed up, you can see it's flickering a lot more. Now, inside of those areas that are flickering, I also want to randomize a little bit more. So we'll take a second noise, and we'll do a math first. So math, drop this in here, and we're going to multiply this. Then we'll take this second noise, and we'll plug this into the bottom, and we'll give this a larger number. We'll also round it. We've got the large noise controlling the overall flicker in the large areas, and then we've got the secondary noise, which is adding more interior flicker to that. So it just breaks it up a little bit more. And the higher we turn this, the smaller those areas. Let's try putting this to 1, maybe 5. So you can see what I mean there. I've changed it to 5. We've got these smaller areas. Let's go with 20 or 50. Then we can also add a bit of distortion, just until we get an effect we like. We also need to animate this, of course, so we go with frame. And now we're getting this sort of an effect. I'm just playing around with the noise settings, just until I find something I like to look up. I think that looks pretty good. Go back into camera view. And what else could we do? I think the last thing, just to finish up, well, there's two things we could do. We could add a little bit of camera movement to it. So let's do that quickly. Select the camera. And just for speed, I'm going to use the old-fashioned method. But if you want the more powerful new method, just check out my video that I posted yesterday. And that will show you how you can use geometry nodes to animate the camera as well. But just for speed, I'm just going to go into do it this way. So on frame 1, camera selected, I press I to add a keyframe just to the rotation. And then go into modifiers, and I'm going to add a noise on the X. Let's turn this up a bit. You can see that's starting to make it bounce around. Turn the strength, we'll turn the scale up. Let's zoom in so we can actually see it. That's a bit too intense. We'll turn the strength down to something like 0.1 or maybe 0.05, something like that. We can copy that and we'll copy it onto the other ones. So onto the Y, and then we'll select the Z one and put it onto the Z as well. And now we're getting this sort of behavior where it's wobbling all over the place. And we can also offset them to make sure they're a different result on each axis. I mean, if we wanted to, we could probably make it much faster. You know, maybe 1. And it's going to be really jittering around, which I think would be more appropriate for the situation, considering she's been electrocuted. And the very final touch is to add some noise. So we need an audio track. Let's just pause that, and we'll go into the video editing workspace and make sure we're back on frame 1. And I've got an audio file. Let me see if I can find it. So dragging an audio file. A good place to get audio files, by the way, is freesound.org. Just type in what you want. So like electricity. It'll give you a load of results. And then click on Creative Commons. And this will ensure that all the ones that it shows you, you can use in commercial products. Just download what you want and then drag it into Blender. So once you've dragged it in, you go back to the, we press play. And then you've got that sort of result. Let's go back into video editing. Turn the volume down, a bit lower. And I'll turn the pitch up as well. That's better. And back into layout. And final step, obviously, render it out. So what I will do is go onto the render output settings, make sure I save the file. I'll save that. So we'll go into the output. We need to give it a location to save to. So I'm just going to save it to the root directory of the Blender file. So // I'll give it a new folder called render output / and give it a name, Suzanne. And then all we can do is make sure we change it to a video format like MPEG, and then change the encoding to, I change it to MPEG 4 so it's compatible with other software. And then the audio, make sure you change this to something as well. So AAC is what I normally go with. That will just ensure that when you render your video, it's going to render out the audio as well. Now at this point, we've got two options. We can go into the compositor, turn on use node, press F12, and it'll render us an image. And if we Control-Shift-Click on this, it will give us the image, and we can make further tweaks to it. Now, one tweak you might like to make, let's just get rid of this timeline at the bottom. So I'm alt middle mouse dragging that to move it around. One thing that might look nice is a bit of chromatic aberration. So go into the lens effect, drop that in, and then just add a bit of distortion. One's going to be way too high, and it's going to be longer to process as well. So maybe 0.1, something like that. And make it fit the screen so we don't lose the edges. And we could add a bit more glare if we wanted. So Shift-A, S, glare. And maybe make it something like ghosts. And give it a bit of color modulation. And then we're going to get this really nice effect there. And what we can do now is, I'll just save it again because I like that effect. We'll do Control F12, and that's going to start rendering the animation for us. And then when the animation's finished, which shouldn't take too long. In fact, hang on. Not sure, like, that's a bit too much, that. Let's press escape. Right. I think I know what the problem is. We've not got any environment set up. So if I go to Scene World, we're going to get the same effect in here that we're getting in that final render. So what we need to do is set up an environment. So we're going to Shader Editor, World, we'll add an environment. So Shift-A-S, just to give it some reflections. We'll choose a map, a HDR, going wherever you keep your assets, 3D assets, HDRI. Let's see what we've got. Let's try that out. And we can turn the strength down by going maybe 0.1, and then we can rotate it. Control T on this if you've got Node Wrangler installed. We can then rotate that around. Maybe a different HDR actually. Let's try. Let's see what it looks like through the camera view. I'm going to camera settings. Just going to turn off the turn up the passive part out so we can only see inside the camera. And let's rotate this around till we get a nice reflection. If I don't want to see that in the background, what I can do, Shift-A-S, put down a light path, and then Shift-A-S, mix RGB, plug this in between the HDR and the background, and then we can say, for the camera, I just want to see black. I'll still get the reflections from the HDR. So like this. But I won't be able to see anything. But that's completely up to you. If you want the background in there, then you know, whatever you want. So let's go back into the compositing. Now we've got an environment. We'll try F12 again. And that's looking way better. So I'll just try making a few tweaks now to the glare node. The mix fact parameter will control how much is output of the effect. If you use a negative number, -1 means no effect. Positive number is just the effect. So if you just set it to 1, you're only going to get the effect output instead of the original image. And if you have it on 0, then it's going to output both. The threshold will control the strength of the pixel required in order for that effect to be applied to it. And then you've got your iterations, which is how good it's going to look, basically. The higher the iterations, the longer it's going to take to process. So this is going to take a bit longer to render, because when it renders, it's going to have to process that again for each frame. If you can't be bothered to wait, and you're not bothered about all these nice extra effects, there is another way to render, which is incredibly fast. So we're going to View in the viewport and choose Render Viewport Animation. And you'll see there, it's rendering similar speed to what you'd get if you were playing back in the viewport, a little bit slower because it's got to write the file. But it's very fast. You can see basically this animation is going to be finished in less than way under a minute. So if we play this back, you can see we've got the animation finished. But I really like that effect I got from the compositor. So I'll press Control F12 this time, so it does a proper render. And then it's going to take much longer. You can see it's going probably a frame a second. So I'll let that complete, and then we'll have a look at it. So let's play this back. There we go. Maybe it would have been better without that, without the ghost. Maybe, I'm not sure actually. It looked nice on the still frame, but on the animation, I think it's a bit too, a little bit too overpowering. So maybe leave that off. It's up to you though. Have a play around. You've got loads of different things you can add on there. Not just ghosts. You can add streaks. You got fog glow, simple stars. Oh, that's quite nice. Yeah, I think that looks much better. So I'll just quickly re-render that. Let me just change the lens distortion a little bit. Yeah, that was pretty good. So I'll re-render that again, and then we'll check that out. And yeah, I think that looks way better. So thanks for watching, and don't forget, If you would like to have an in-depth knowledge of how geometry nodes work so that you can come up with these sort of concoctions yourself without the need to watch tutorials, then check out the EEVEE Huge Oceans Part 2 tutorial available from 3d-illusions.co.uk, and that will, in my opinion, be the quickest route to having an incredibly deep understanding of how geometry nodes works so that you can create whatever you want. So thanks again for watching.